With the time passing, I've realized that we are talking more and more about measurement strategies and how to use measurement software. But I think the most important part is to really know what are the biggest influences for a measurement and how to have accurate, efficient, and comparable measurements. So, welcome back to my channel everyone, and if you really want to support my work, you can now do that on YouTube as well. Because thanks to you, I can now have channel members. So, special content will be uploaded for members from now on. Members will have earlier access to any new video that I will upload. And just for you to know, I am planning to buy a better camera to make even good content, record even real measurements, and I am planning to buy a PCDMIS license to continue making tutorials in PCDMIS as well. So all the money raised from the subscribers on Patreon and from the subscribers on YouTube will go into equipment and will go into better content for this channel. So as the saying goes, help me help you. With that being said, let's start. We can all notice that technology is part of our life more and more in the last century, and that the required quality standards are increasing considerably and the manufacturing tolerances are tighter and tighter. Every company is choosing the suitable measurement device that it needs, but regardless of what that equipment is, it's important to have in mind the golden rule of metrology defined by Professor Bernd Gerg. The measurement uncertainty of any measurement equipment should not exceed 1 per 10 of the specified tolerance. So, that is actually 10% of any tolerance. Keep this in mind if you are about to buy your first measurement equipment. What is your smallest tolerance? Then, take in consideration what measurement equipment to buy. This action alone can save you lots and lots of money. Instead of buying a measurement device that costs $100,000, you can buy something worth $30,000 and still be enough to check your parts. Informed actions lead to smart decisions. Going from this information, you can ask yourself another question: functionality or production? Do you know the differences? Evaluations, clamping, measurement strategies, probing methods are components of the measurement process that varies drastically depending on the usability of the results. Do you use the results for process control or for functional check? So let's have a look at the main measurements that are performed in the process control. We have gauge R&R test, CG or CGK measurements, determination of process parameters, checking process parameters, and so on. And now let's have a look at the main measurements done to check the functionality of a part. First and most important is to ensure the assembly of components. Checking the function of the components, incoming and outgoing inspections, sampling, and so on. Furthermore, we can see a diagram on how this works. Notice that everything starts from design. After this stage is finished, everything goes into planning. What part goes into production? When does it go into production? If there has to be assembly processes, and so on. Then the next step is the production of the part. In the production area, parts are being collected and are brought to be inspected with a measurement device. The results are analyzed, and if the results don't look good, we correct the process and remeasure the parts. This is done until all the dimensions are in specification. If everything is okay, then it's implemented a process control and the parts are being measured regularly to be only verified if everything is okay. Now, when it comes to comparison of the measurement results, a lot of factors come into play. Measurement results obtained by the same measurement equipment with the same measurement room having the same environment conditions can have significant differences if the measurement strategy and the settings done to the measurement software differ. And don't take this subject for granted. In today's industry, comparable results are key to obtaining interdepartmental trust and the trust of your suppliers and clients. So, to summarize all the information, we can have a look at the most important factors that determine errors when it comes to measurement results. The first one is the errors that come from the measurement equipment. Factors like accuracy, measuring range, measuring standards, correction errors, qualifications, calibration errors, damages, illumination, and so on are all being checked. Then we can have the environment, the temperature in the measuring room, the humidity, vibration, light reflection, airflow, and so on. After this, we can have a look at the workpiece itself. How deformed it is, its weight, part temperature, and its linear expansion, contaminations, elasticity, drawing and CAD errors, reflections, and so on. Then we can have a look at the inspector that is measuring or creating the measurement program. Here things like tool handling, clamping correctitude, alignment check, stylus assembly, stylus or laser sensor qualification correctitude, measurement planning, collision avoidance, monitoring the measurement device, cleanliness, and last but not least motivation are things that matter. After this, we can check the measurement strategy. We can have a look at the factors like planning of the task, selection of the right tools like styluses, or the correct choosing of the camera resolution when it comes to scanning technology, measurement methods choose, filtering and outlayering elimination, strategy to make some analysis, clearance and fixturing strategy, alignment strategy, illumination strategy, zoom for some devices, number of measurement points, distribution of points, scanning speed, probing force, and so on. And the last category that have an influence on the measurement results is the task itself. Is it clear enough? Is the tolerance in range of the accuracy? Is the time allocated to the task enough to take in consideration all errors from above? Is it clear what type of data has to be generated at the end of the task, so the results? The measurement volume is capable of such a task or not? And so on. We can go on and on, but you get the idea. You can see what type of influences we can have on the measurement result and why sometimes it's easy to pass some of these categories and not understand where the accuracy, efficiency, or comparison problems come from. If every aspect from this video is taken care of, then you can move to more complex information. Because most of the time the simplest things matter the most. I hope the information was relevant for you. Please leave a like, share and join my channel if you want to learn more information like this in the future. And don't forget, until next time, learn as much as you can.